The fundamental theorem of algebra. Okay, our essential question today will be, how can the fundamental theorem of algebra help me determine how many roots, let's put a polynomial has. How can the fundamental theorem of algebra help me determine how many roots a polynomial has? So when you go home, what are you supposed to do on the end of these notes? What? What are you supposed to do at the end of these notes every day? Write a summary. And the first couple sentences of your summary should be the answer to that question we just wrote, the essential question. Okay, take one of these school newspapers and pass them down. I just dropped them off. Please don't leave it in the classroom if you choose not to read it. Please don't just leave it in the classroom. You can put it in the recycling bin. There you go. Okay, go ahead and tuck the newspapers away, and you can check them out after the notes. Okay, would everyone open up your books, please, to page 296. On page 296, it gives the definition of, oops, it's not writing. Let's try to get rid of that. The fundamental theorem of algebra. Okay, open up to page 296. And in the white box on page 296, it has a definition. It says Theorem 107, the fundamental theorem of algebra. Would you write those on your notes, please? It's 2 lines. Write the definition of the fundamental theorem of algebra on your notes. Emmanuel, can you put the newspaper away until we're done? On page 296. Right here in that white box where it says Theorem 107, just copy it down. The fundamental theorem of algebra is if P of x stands for the polynomial function. If P of x is a polynomial of degree n, so the degree has to be greater than or equal to 1, then when we set it equal to 0, it has exactly n roots. Okay, so if the degree of the polynomial is, say, oops, that was supposed to be colored. Let's try that again. If the degree of the polynomial is like 5, is 5 greater than or equal to 1? Yeah, then the polynomial has exactly how many roots? 5. So it matches the degree. If the highest exponent is a 4, then there exist 4 roots. These roots could be multiplicities, or they could also be complex roots. Okay? And last week we talked about complex roots have a thing called conjugates. Remember, a complex root, I'm going to erase this so you don't have to write this down. But an example of a complex root would be like 7 plus 3i. Because a complex number has a real part plus an imaginary part, or subtract imaginary part. So what would its conjugate be? It'd be 7. Yeah, so if you remember from last week, all that happens is the operation changes. So if we know one complex root and say it's supposed to have 5 roots and we've only found 4 of them, but one of them's a complex root, the other root we're missing is the conjugate. So we just change the operation. The other numbers that have conjugates are numbers that are irrational, like square root of 5. Square root of 5 is actually 0 plus square root of 5. It's a binomial. So what's a conjugate of 0 plus square root of 5? Right, and so we could say that the conjugate is actually just the negative square root of 5. So irrationals and imaginaries, which are the complex numbers, have conjugates. So that's how you can find the extra roots. Okay. So on our assignment today, every problem you're going to be saying how many roots exist, and then you're going to find those roots and label them. Are they complex roots or are they real roots? Okay, and we'll use the rational root theorem that we've already learned to do that. Okay, so for example 1, we're going to, again, example 1, not name, let's do this. Answer how many roots exist, and then we're going to find all roots. Okay, our first polynomial is x cubed plus 4x squared minus 7x minus 10 equals 0. Now, why does it have an equal 0 on the end if we're asked to find roots? Why does it have an equal 0 on the end? M? Because roots and zeros are the same thing. And roots and zeros are located where on the graph? On the x-axis. And if you're standing on the x-axis, what's your height? You're standing right here on the x-axis, what's your height? 0. That's why it always says equals 0, because your height is at 0. Once you go up, you're higher than 0. If you go down, you're lower than 0. But if you're on the x-axis, your height is 0. So when we find roots or zeros or solutions or x-intercepts, that's why we always have it equal to 0. Okay, so rational root theorem is applied to polynomials that are larger than quadratics, because quadratic is x squared, right? So this polynomial is larger than an x squared. It's larger than a quadratic. So show me with your fingers up in the air how many roots exist, because the highest degree tells us how many roots exist. There's more than 2 because it's higher degree. Thanks for showing me. Allison, how many roots? Yeah, good. 3. So that's our first answer. There are 3 total roots. Now we're going to go find those. These roots could be, all of them could be real numbers. We can find them, or they might be complex numbers. but 3 exist. Okay, so we use the rational root theorem to figure it out. Does anyone remember from the last 2 lessons how to do the rational root theorem? What do we start with? Factors, good, of which number? The constant, which in this case is, there you go, factors of negative 10. Okay, on your paper, go list the factors of negative 10, all of them, positives and negatives. Positives and negative factors of negative 10. Okay, turn to your neighbor and tell them your factors. Check to see if you guys got the same ones. Okay, Adam, what are your factors? Great. That's correct. Okay, now we list factors of what? Of the leading coefficient, which you guys are right, is 1. The leading coefficient. So you do the factors of the outsides. You start with the constant on the far right, and then you do the factors of the leading coefficient on the far left. Okay, the only factors of 1 are plus and minus 1. Okay, after we have the factors for the numerator and the denominator, hint, hint, numerator and denominator means what do we do next? Divide. So we're actually having a fraction here. We're going to divide those and list all possibilities. Which in this case, if our denominator is dividing by 1 or negative 1, aren't all the possibilities just the numerator? Yeah. So that'd be plus and minus 1, plus and minus 2, plus and minus 5, plus and minus 10. So it means we have 10 possibilities, but you guys told us at the beginning only 3 actually exist. So 7 of those aren't going to be roots, if all of them are real. It could be that we have some imaginaries, so there'd be complex roots. Okay, so after we have all our possibilities, how do we know which ones are the real ones, the real roots that exist?
We guess.
You don't guess, no. Let's find the probability of him guessing correctly. Oh, we do a chart. Good. Okay, on the top, we list all of our possibilities. Positive 1, negative 1, all the way through. So that's 8. And assuming that all the roots are actually real numbers, we could fill in the whole chart. But the chart does pose a problem if we come up with any complex numbers, because our list of possibilities are actually all the lists of the rational possibilities. So irrational numbers and complex numbers aren't rationals. Okay, so we go through and we plug them in, and once we find one of them, we can stop filling in the chart. If you like the chart, you can keep going through the whole chart. But once we find one root, we can divide it out using synthetic division. Okay, so let's have this side of the room do positive 1, and you guys do negative 1. So remember right here is our original polynomial. Anywhere there's an x, you put parentheses. So we have parentheses cubed plus 4 parentheses squared minus 7 parentheses minus 10 equals 0. Inside the parentheses, you put your value that you are assigned. Okay, if you've filled out your calculator use agreement, get your calculator. You can get that at the beginning of class. So you guys are doing 1, and you guys are doing negative 1. Even if you don't have a calculator, you can do this by hand. If you have a calculator app, you can use that as long as you're not going to anything else on your phone or your iPod. Okay, on the one side, Styles, what did you guys get? Does anyone else agree with that from your group? Do we have a second? You second? Okay. What about the -1 group?
0.
Ah, 0. We found one. Yay. Okay, so that means -1 is a root. So we're going to divide it out now using synthetic division. -1. Put that in a box. Remember synthetic division? First, we'll do the steps in just a sec. Let's get the coefficients first. Okay, looking back at our original polynomial right here, let's shout out the coefficients. What's the first coefficient? 1, 4, -7, -10. 1, 4, -7, -10. Then leave a line of space. So the rules again are you add the columns. Any numbers underneath the line get multiplied to the box. Any number under the line is multiplied to the box number, whatever's in the box. Okay, so we add up the columns. 1 plus nothing underneath of it is 1. Now when I take this 1 and do what with it? Times by -1. Heather, did you just get here? Did you check in at the office? If you're more than like 20 minutes late, you have to check in at the office. Will you go check in with Betty? Okay, then we add up the column again. 4 plus -1 is 3. Anything underneath the line, we multiply to the box, right? So Cassie, what do we get for our value underneath the 7? 3 times -1 would be -3. Good, and then we add them up, which is -10. Multiply to the box, and we get +10. Add them up, and we get 0, which is what should happen. If -1 is actually a factor, or not a factor, a 0 or a root, then we should have remainder 0, because it means it divides evenly. And anything that's a factor does divide evenly. So -10 is our constant, 3 is the first x, and 1 is the x squared, and put a little plus in front of the 3 since it was positive. So now we have a trinomial. 1x squared plus 3x minus 10. And do we know how to factor x squared plus 3x minus 10? Do we know how to factor quadratics? Yeah. Remember? You guys did this before. X squared plus 3x minus 10 is what? What do we put on the top? For two numbers that multiply to -10 and add to 3. Good. So think about it. What two numbers multiply to -10 and add to 3? Okay, I hear -5 and 2, and I also hear +5 and -2. Which one adds to +3?
2 and -5.
That adds to -3, actually. So in order to get a positive, the smaller number needs the negative sign, right? Good. Okay, so those are our factors. we have x plus 5 and x minus 2. Once again, these are factors, but the directions said find the roots or the zeros. So if we have factors, how do we get roots and zeros from that? Set them equal to 0. So I hope you notice a common theme that we've been doing this for weeks now, and it's factors and zeros. We do the same step every time. Once you have a factor, you set it equal to 0. And we get x equals negative 5, and this one you can just do in your head, x equals positive 2. But this is only two zeros. Weren't there supposed to be 3? At the very top we said there were 3. Ah, good. We already found that one. It's right here, right? That number in the box is also a root. X equals negative 1. Okay, and on your homework you're supposed to say what types of roots these are. Are these complex roots? No, these are 3 real roots. 3 real roots. Okay, any questions on that problem? Are you starting to become a little more comfortable with rational root theorem? Just a little bit, at least? It's kind of a crazy theorem, but it takes a lot of work. Okay, we're going to do one more practicing, because this is everything you do on your homework today is what we just did on the last problem. You say how many roots exist, and then you find them, and tell me, are they complex or are they real? Okay, example 2, which is the last one for our notes, is x to the 4th minus 16 equals 0. X to the 4th minus 16 equals 0, yeah? Yeah, if you filled in the whole chart, because the roots were all real, you would get the same answer. But on this next one, there's going to be some that aren't real, and then you come into a problem because you can't find them by doing the chart. The chart only helps for rational roots. So if there's any complex roots, then you're going to have a problem. Okay, check out the polynomial. How many roots exist? Hold it up in the air. How many roots exist? These could be real roots, or they could be complex, or a mixture of both. Thanks for holding it up, because we can tell by the highest degree it is 4, right? Okay, now also, this one has some gaps that need to be filled in. We need some placeholders in the middle here, because x to the 4th is there, but how many x cubes are there? There's 0 x cubes, and we're going to need these placeholders. How many x squareds are there? There's 0 of them. How many x's are there? 0. And then how many constants? Negative 16. Okay, so we need the placeholders. So it should be decreasing x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, and minus 16 is x to the 0, which is why it's not written. Okay, so you guys already told us that there are 4 total roots. Now we have to go find those using the rational root theorem. So we find factors of, which one, Gentry? Good, the factors of the constant. Factors of negative 16. Okay, everyone go write your list of factors. Did she give you a note, Heather? Okay, list all roots of negative 16. Okay, you should have Plus and minus 1, what would be next? Plus and minus 2. Good. Good. And good. 16. So in reality, we have 10 factors of negative 16. Then we do factors of what number? Of 1, which is the leading coefficient in front of the x to the 4th. Factors of 1, which are just plus and minus 1. Okay, Joseph, what do we do after we have both lists of factors? Divide. Good. In this case, again, if the leading coefficient is 1, then this list of all possibilities, it's actually just a list of all possible rationals. List of rational roots. Because we could have some complex roots. So the plus and minus 1 is just the numerator when we divide by 1. Okay, Gucci, what do we do now after we have all the list of possible rational roots?
So we put them down.
Put them down in what?
Put them in that weird.
Start with a C. Chart. There you go.
And then we put them
Good. Okay. So we'll put in 1, negative 1, 2, negative 2, 4, etc. Now this is a lot. Okay, you want to know a shortcut to figure out? Because you could plug all of them in, but there are 10 to plug in. We need to find 1 before we can just start using division. So if you have calculators, you could use your calculator as a tool to jump a little bit to get to the one that will work right away. Also, by raising hand, who doesn't have their own calculator, their own graphing calculator or app? Okay, if you have a home computer, you guys have a home computer? No? Well, if you do have a home computer, let me show you what you can do. This has been on my website forever. Okay, it's coming up. Oh, I probably should go to the real instead of my login. Okay, raise your hand if you've been here. Oh, a few people. That's good news. The rest of you should show up to this website once in a while. Okay, you have your secondary 3. Click on secondary 3, and there's a calculator right here for you to install. It's free. It's called, you click on the link called TI-83 Plus SDK link. Then press continue as guest, and these are just the instructions of how to install it. So right here, yeah, that's how many times it took for me to install it on my computer. TI-83, I click it, and look, isn't this the same calculator we're using in class? Well, yellow, but it's the same. Yeah, it's similar. Okay, then right here, you click on that. Girls, are you paying attention? Yeah. Push continue as guest, and then you just go through the install. I'm not going to install it on this computer because I already have one. But you just go through the install features, and it's just like the one I'm using, that I use in class, right here. It's coming. So this is a way, it's free, it's a way for you to have a graphing calculator available for your homework if you don't have one. Okay? I haven't tried it on a phone. You can try it. I haven't tried it though on a phone. Okay? Everyone with your calculators go to y equals and type in our polynomial x to the 4th minus 16. There's also graphing apps that are free. They don't look exactly like this calculator, but they still work if you have something that can get an app. Okay? And then what if your window, if you graphed it and your window was messed up? How do you fix the window? You can click window and just type them in by hand, or you can go to Zoom, and the one that will jump right to a standard window is called Z standard number 6. Okay, we graph it, and roots, remember, are where the graph crosses the x-axis. So can you see right off one of those that would work from our list? 2 would work, right? So let's go divide it out. Go back to your notes. And let's plug in 2. And I can't remember, was it Gucci who was telling us? We plug it into the original polynomial, which for us, we need this one, the placeholders. So wherever there was an x, you plug in 2. Oops. Wherever there was an x, you plug in 2. I'm having a hard time writing this. 0x minus 16. What happens here when we multiply by 0? What happens here, here, and here when we multiply by 0? It's 0. Those go away. Hi. Yeah. Okay, and when we plug in 2, what's 2 to the 4th? Means 2 times 2, which is 4 times 2, which is times 2, 16. Minus 16 equals, so it did work. Okay, so, I'm sorry? Yep, it would as well. Okay, so we're going to take the first one we found, which is positive 2, and we're going to divide it out. Now, we're going to use the coefficients, which is why it was very important that we use those placeholders. What's the first coefficient? 1, and then 0, 0, 0, negative 16. 1, 0, 0, 0, negative 16. Okay, I want you to try the synthetic division. Remember, you add up the columns. Try it on your paper right now. Add up the column. Once you get a number underneath the line, that number is multiplied to the box, which in this case is a 2. Try the synthetic division by yourself. Add the columns. Anything under the line gets multiplied to the box. Okay, so the first column. This is what you should have on your paper. If you don't, fix it. Most people look like they're doing okay. Bring down the 1. Then we do 1 times 2 is, shout it out. Good. Add them up. Now 2 times the box is 4. Then you add them up. 4 times the box is, add them up. 8 times 2 is, add them up and we get 0, which is what should happen. If you don't get 0, then you know that you need to go check something. Okay, that's remainder 0. 8 is the constant, so it's a positive 8. What does 4 get? An x. Positive 4, x. What does 2 get? X squared. And what does the 1 get? X cubed. Okay? When we were on our calculator, didn't you notice that there was another root? Negative 2, because here's our calculator. Now we're going to go divide out negative 2. Oops. So we're going to do it again. You're going to get lots of practice on synthetic division today. Dividing out negative 2, because once we can't use our factoring methods until we get to a quadratic, and we're still at a cubic right now. So the coefficients are all these in blue, but we don't use the remainder. 1, 2, 4, and 8. 1, 2, 4, and 8. Okay? Try it again. Using for negative 2, even though that marker is in, there we go. Still in the way. That's negative 2. Synthetic division. The first column, all you do is bring it straight down because there's nothing underneath it. Then times by the box. Did you get a remainder 0? Okay. What is 0 times negative 2? 0, so that's where you made the error. Excuse me. Good. I'm glad of it. Excuse me. Bring down the 1. Okay, what's 2 plus negative 2? That's 0. That needs to be a 0 down there. Yeah, you add the column. And then negative 2 times 0. What's negative 2 times 0? Then add the column.
Also, so before.
Yep, and negative 2 times 4 is negative 8. The remainder is 0. So now it's good. Good. Looks like we're getting it. So, we do 1 times the box, which is negative 2. Add it up. And 2 minus 2 is not 4, or negative 4 is 0. Also, 0 times anything is 0. Add it up. 4 times negative 2 is negative 8. Okay, so after you get to this point, you should throw in your remainder 0. 4 is the constant, 0x, and x squared. Okay, which really gives us a quadratic. So now we look at what two numbers multiply to 4 and add to 0. Once we're to a quadratic, we can use our factoring methods. What two numbers multiply to 4 and add to 0? Joseph? Negative 2 times negative 2 is 4, right? But is negative 2 plus negative 2 0? Ah, no, it's not. Okay, so the only way to add 0 is we need a positive 2 and a negative 2, right? But is positive 2 times negative 2 positive 4? Oh, shoot. Ah, with the real numbers, it is not possible. So, last year, you learned a formula that helps us with these ones that are not possible, because it's not going to be a real root. It's going to be a complex root. Or it could be an irrational, I guess. Okay? Who went to the talent show last year? Because I was in this. I was the one wearing the brown wig. Remember? What helps us? These are called quadratics, aren't they? Don't we have something called a quadratic formula? Ah, what's the quadratic formula, guys? The quadratic formula is negative b plus or minus square root b squared minus 4ac all over 2a. Or who went to the talent show? Remember this one? The Adele version, the whole math department of the talent show last year? It's negative b plus or minus square root b squared minus 4ac. And then Miss Bergstrom would turn around all over 2a. Remember that? Don't swap the talent show, people. You missed a great act by myself. Mr. Meekin, he was another singer, and then the other math teachers were holding up posters. It was at the end of the year. Yep. It was a hit, I tell you what. Okay, so we can use the quadratic formula. Another way is, I noticed right off that when there's only, because the middle term is 0, there's really only two terms, x squared plus 4. When you only have the two terms and you don't have that extra x to the first power piece, you can just solve it. How do we solve for x? Subtract 4. Which leaves us x squared equals negative 4. Ah, what's the inverse of squaring? Square root. Okay, so we need to know, what is the square root of negative 4? Ah, it's imaginary. Why? When you take in the square root of a negative, it becomes imaginary. So, what is the symbol for imaginary? I. This will be plus or minus 2i. So here are two roots, but these are complex roots. Actually, put 2. Remember, we're supposed to label. we have two complex roots, but this was originally x to the fourth. Didn't we find two other roots at the beginning? What were our two roots in the boxes? -2 and +2. So plus and minus 2. Are these, guys, are these roots complex roots? No, what type of roots are +2 and -2? Real roots. So we also have two real roots. And we already wrote this at the top, but in total there were 4 total roots. Yeah, it is long, so I'm being very kind. For our homework tonight, we only have 6 problems, because I get that they're super long. There's just one thing we're going to draw in our notes, and then we're done. The fundamental theorem, okay, I need everyone listening. Guys, we're just going to draw a couple pictures. You don't even have to work out another problem. The fundamental theorem of algebra. Okay, I'll wait for you. The fundamental theorem of algebra tells us how many total roots there are. Now, if they're real roots, or irrational roots, which are also real, I guess, if they're real roots, then there's actual places on the graph that the graph crosses the x-axis. So, for instance, whoops, a quadratic has two total roots, right? If those roots are both real, two real roots, it means that the graph crosses twice. Okay, a quadratic is a U-shaped parabola. It can go up or it can be opening down, but it means it crosses twice, like that, right? What would the graph look like if we had one real root? Because there is a multiplicity. How would it be possible for a quadratic to only cross the graph once? But can only cross the x-axis once. Or touch the x-axis. Doesn't necessarily have to cross. It can only touch the x-axis once. Well, it's still going to be a quadratic, so it's still going to be this U shape. Does this touch the graph once? So that's how you could get one root, which is when kind of you have multiplicities. When you have 0 real roots, for instance, maybe all of our roots end up being complex. That means the graph never touches the x-axis. So an example of that would be a graph that was shifted up, like that, or one that was shifted down, goes like that. Okay? Where it never touches the x-axis. Any questions? Okay.